Now what we're going to do is talk about a part of the quadratic formula called the discriminant and how it can be useful for us. In the previous examples, we had a couple different quadratics and we had a couple different types of solutions. We had rational solutions, we had irrational solutions, and we had non-real solutions. The first example, example A, that we had on the previous page with 3x squared plus 16x plus 5 equals 0, had two real solutions, negative 1/3 and negative 5. And that graph is shown over on the right here with the red line. We also had another example where x equals negative 3x squared minus 3. And that equation had no real solutions. We saw that we had the imaginary solutions because the radicand was negative 35, giving us two non-real solutions. That graph is shown there on the right in blue. I want you to think about the solutions to the two quadratics that we had there and how those solutions appear on the graph of the quadratic and how they relate. So when we take a look at the red graph and we consider that we had solutions of negative 5 and negative 1/3, what we can notice is that our x-intercepts appear at those points. We have an x-intercept of negative 5, 0, and what looks like approximately negative 1/3, 0. So we have x-intercepts there for those two solutions. The blue graph, however, doesn't have any x-intercepts. There is nowhere on the x-axis it touches because it opens upward and it's above the x-axis. So the no real solutions translates to no x-intercepts. This is something that the discriminant can help us identify. In the quadratic formula, the radicand, the b squared minus 4ac, is called the discriminant. And this is because it allows us to discriminate among the possible number of and types of solutions in a quadratic equation. It also tells us the number of intercepts by its very nature. So let's think about how the value of the radicand can affect the number and the types of solutions. So I have this little chart here, and we can consider the types of numbers that we had. Well, starting out with a positive solution. Okay, so if I get a positive value, what does that mean about my number of solutions? Well, when the value is positive, let's take a consideration here. If I have something like the square root of 25 as my radicand, negative b plus or minus over 2a, or if I had something like negative b plus or minus the square root of 20 over 2a. Okay, so my radicand for both of these cases is positive. Well, that means I can go ahead and I can actually take the square root of this one on the left. So I have negative b plus or minus 5 over 2a, and whatever b and a are, I can actually go ahead and evaluate those. And here I have negative b plus or minus 2 root 5 over 2a, and then I can continue to simplify that. So in this case, where my radicand is positive and a perfect square, I'm going to get two different solutions. I'm going to get two solutions, and those are both always going to be rational solutions. And they will be real numbers. And if I have a positive, but it's not a perfect square, and I can simplify it, I still get two solutions because of the plus or minus. I just get two irrational solutions. So if my discriminant is positive, I'm always going to have two solutions because I have the plus and I have the minus. I have the addition and I have the subtraction of whatever the radical expression is. And then the type of solution is it'll always be a real number. Positive radicand means I'm going to have two real number solutions. Now, another way that we can think is, well, what if I have a negative? Well, we talked about that earlier. And so if I had negative b plus or minus the square root of negative 25 over 2a, if my radicand is negative, well, then that means I'm going to have non-real complex solutions. I'm going to have non-real complex, but because I have the plus or minus, I'm still getting two solutions. I have two non-real complex solutions. Non-real complex numbers. Well, you say, okay, well, both of these cases I get two solutions. Is there ever going to be a time where I don't get two solutions? Well, we looked at what happens if we get positive solutions, what happens if we get negative solutions, and we have to think of, okay, what type of number is neither positive nor negative? Well, and the answer to that is 0. So if our discriminant is 0, then we're going to get a different set of criteria. And so we consider that, well, if our discriminant is 0, I have negative b plus or minus the square root of 0 over 2a. The square root of 0 is 0, so I have negative b plus or minus 0 over 2a. And whether I add 0 or subtract 0, there's no difference. And so I'm just left with negative b over 2a, and I only have one real solution. So if the discriminant is 0, that is the only time we're not going to get two solutions, and instead we're only going to get one real number solution. Now, side note, the discriminant is also a really useful way for us to determine whether or not we can factor. So by considering this problem and the types of solutions we get, in order to factor, our solutions have to be rational. In order to factor, the solutions must be rational. So let's consider in what cases our solutions will be rational, and then we can factor. Well, when the discriminant was a perfect square, we were able to get rational solutions. So when our discriminant is a perfect square, that means that we can factor. The other case where we got rational solutions was when our discriminant was 0. So if our discriminant is a perfect square or 0, then that means that it is a factorable polynomial. So let's use the discriminant to determine the number and types of solutions for each quadratic equation. And we're not going to solve. And I'm going to add on to this, and I'm going to say that I also want you to determine whether or not we would need to use the quadratic formula to solve, or if we would be able to factor to solve. So again, our discriminant is b squared minus 4ac. That's the only part of the quadratic formula we're going to solve. We're not even going to include the radical. So we look at our quadratic in standard form. A is 1, b is 2, and c is 1. So we can evaluate the discriminant here. We have 2 squared minus 4 times 1 times 1. And we want to see what that equals. So we get 4 minus 4 equals 0. So the value of the discriminant is 0. Then, because our discriminant is 0, we mentioned that if the discriminant is a perfect square or 0, then that means it is factorable. So this polynomial is indeed factorable. And that's going to be important for later units, being able to easily and quickly determine, can I factor this polynomial, or do I need to use quadratic formula? Here we have another quadratic. We are in standard form because it is set equal to 0. So our value of a is 3. Our value of b is 0 because there is no linear term. And our value for c is 2. So we use our discriminant formula, b squared minus 4ac. So we have 0 squared minus 4 times 3 times 2. So we have 0 minus 24, which gives us negative 24. So the value of our discriminant is negative 24. I just realized I forgot to give the number and types of solutions. Since our discriminant was 0 over here, that means we're going to have one real solution. And as a side note, it is also going to be rational. Here, because our discriminant is negative, we're going to have two non-real solutions. Two non-real solutions. So here can make sure that we are in standard form and we are set equal to 0. The value of A is 2, B is -7, and C is -4. So we'll use our formula, B squared minus 4AC. -7 squared minus 4 times 2 times -4. We get 49 plus 32. Then when we add those together, we get 81. So the value of our discriminant is 81. That means we are going to have two real solutions because it is positive. It also means that this is factorable because this is a perfect square. The square root of 81 is 9. So because it's a perfect square, we know that this polynomial is factorable. This polynomial is not factorable because we have two non-real solutions. Anytime we have a negative discriminant or the discriminant is not a perfect square, we have to use quadratic formula in order to solve if we need to solve it.